Imagine receiving a phone call from someone who left home before your parents were born. Someone so far away that every sentence they speak takes an entire day just to reach you. You ask a question and you wait. Not minutes, not hours. An entire day passes before the answer arrives. And now imagine knowing, somewhere in the back of your mind, that one day the phone will ring for the last time. Not because the line was cut, not because anything broke, simply because the voice on the other end will finally run out of strength to speak. That is happening right now, not in a story, not in a simulation. Somewhere past the edge of everything we call home, a machine built by human hands is still calling Earth, growing quieter with every single word. Its name is Voyager 1. Before we go further, if you're fascinated by the greatest mysteries of space and the universe, subscribe to Beyond Cosmos, because we explore stories that make you see the cosmos in a completely different way. Now let's begin. To understand why this matters, you have to go back to a moment when nobody expected any of this to happen. On September 5th, 1977, a spacecraft roughly the size of a small car lifted off from Earth. Its mission was supposed to last about 5 years. Visit a couple of planets, take some pictures, send back data, then quietly fade into irrelevance like so many missions before it. Nobody involved in that launch believed they were building something that would still be listening for their voice nearly half a century later. Voyager 1's first real test came at Jupiter, the largest planet in our solar system. It revealed storms larger than Earth itself, moons with volcanoes actively erupting, a world far stranger than anyone had imagined. Then it moved on to Saturn, capturing details of its rings that no telescope on Earth could ever hope to see. But here's what makes this story different from an ordinary planetary tour. Every time Voyager 1 passed a planet, it used that planet's gravity like a slingshot, borrowing a tiny piece of its momentum to hurl itself even faster toward the next destination. This technique is called a gravity assist, and it did something almost poetic. It meant that the same forces holding our solar system together were the very forces flinging Voyager 1 out of it. By the time it finished its planetary tour, Voyager 1 wasn't just successful, it was moving faster than any spacecraft humanity had ever built, on a trajectory that would carry it beyond anything we understood as home. But leaving the planets behind wasn't the same as leaving the solar system. That distinction matters more than most people realize. Our solar system isn't defined by planets. It's defined by the sun's influence, a massive bubble of solar wind and magnetic pressure called the heliosphere, extending far beyond the last planet, surrounding everything familiar to us like an invisible shell. Voyager 1 had to cross through layer after layer of that boundary. First, the termination shock, where solar wind suddenly slows down. Then, the heliosheath, a turbulent transitional zone. And finally, in 2012, it crossed the heliopause, the true edge where the sun's influence ends and the vast emptiness between stars begins. For the first time in human history, something we built had left the sun's bubble entirely and entered interstellar space. Try to picture that scale for a moment. If Earth were sitting in your living room, the moon would barely be an arm's length away. Mars would be somewhere down the street. Pluto would be miles outside your city. And the heliosphere's edge, the actual boundary Voyager 1 crossed, would still be much, much farther beyond that. We are talking about a distance so enormous that light itself, the fastest thing in existence, needs real time to cross it. And that brings us to one of the most quietly devastating facts about Voyager 1's current situation. It is now more than 1 light day away from Earth. That means a radio signal, traveling at the speed of light, takes roughly 24 hours just to reach it. And Voyager's response takes another 24 hours to come back. A single question, a single answer. Nearly 2 full days for one exchange. Every conversation NASA has with Voyager 1 now unfolds slower than almost anything else in human experience. But that wasn't the most incredible part. Voyager 1's transmitter broadcasts using about 23 watts of power. That's roughly the same wattage as the light bulb inside your refrigerator. And yet, across more than 25 billion kilometers of empty space, Earth's deep space network, a collection of massive radio dishes built specifically to listen for signals this faint, still manages to detect it. Engineers are essentially straining to hear a whisper carried across a distance that swallows imagination itself. What happened next surprised even NASA. Voyager 1 doesn't run on solar panels. Out here, sunlight is far too weak to power anything. Instead, it relies on radioisotope thermoelectric generators, devices that convert the heat from decaying plutonium into electricity. It's an elegant solution, but not an eternal one. Every single year, Voyager 1 loses about 4 watts of available power, slowly, permanently. There is no way to refuel it, no way to send a repair crew, no way to reverse the decline. And that's when engineers faced an impossible decision. As the power kept fading, NASA had to start choosing what to sacrifice. Voyager 1's cameras were shut down decades ago, long before most of us ever heard its name. One by one, other instruments were switched off. Not because they broke, but because keeping them running would have meant losing something else more important. In April of 2026, NASA made the difficult call to shut down the spacecraft's low-energy charged particles experiment, one more voice silenced to keep the rest of the mission alive a little longer. Only a small number of instruments are still active today. Each year, that number gets smaller. Somewhere in a control room on Earth, people are making decisions about what a machine floating in interstellar darkness is allowed to keep sensing, and what it must finally stop perceiving forever. But Voyager's greatest achievement wasn't reaching interstellar space. It might have been what happened in 2023. That year, Voyager 1 suddenly began transmitting nonsense. Garbled data, meaningless code. For a spacecraft this old, this far away, this fragile, it looked like the beginning of the end. Engineers traced the problem to corrupted memory inside a computer system designed in the 1970s, using technology that predates the personal computer as we know it. Then the story took an unexpected turn. With a communication delay of nearly 22 hours in each direction, meaning any single command took almost 2 days to send and confirm, NASA's engineers began the delicate process of diagnosing and repairing a computer from another decade across a distance that made every attempted fix feel like defusing a bomb through a mirror, blind and with no room for error. And somehow, against everything reasonable, it worked. Voyager 1 spoke clearly again. One of the most remarkable technical recoveries in the history of space exploration, carried out entirely from a distance human beings can barely comprehend. Many people assume Voyager 1 is just drifting now, silent and purposeless, a relic coasting through darkness. That isn't true. It still measures cosmic rays, the high-energy particles racing through the galaxy. It still detects magnetic fields, plasma waves, and the strange properties of the interstellar medium itself, the thin material that exists in the space between stars. No other spacecraft can gather this information because no other spacecraft has ever traveled far enough to reach it. Voyager 1 remains, for now, humanity's only observer standing directly in interstellar space. But the final chapter of Voyager's story may already have begun. Every year, its power supply weakens further. Every year, another decision looms about what to shut down next. Eventually, and nobody knows exactly when, NASA will send a routine command out into the dark, and for the first time, nothing will come back. Not silence caused by a crash, not silence caused by damage or destruction, simply silence caused by the absence of enough power left to answer. Nobody knows which message will be the last. Nobody knows if it's already been sent. And that's when Voyager 1's story shifts from science into something closer to memory. Because even after its voice goes quiet forever, the spacecraft itself won't stop moving. It will continue drifting through the galaxy for thousands of years, then millions, long after every star we can currently name has changed, long after the last radio dish on Earth has been dismantled or forgotten. Voyager 1 will still be traveling outward, carrying something extraordinary with it. Attached to its side is the Golden Record, a phonograph disc containing sounds and images meant to represent life on Earth. Music from different cultures across our planet, greetings spoken in dozens of languages, the sound of human laughter, the songs of whales moving through our oceans, a fragile, deliberate attempt to say, if anyone out there ever finds this, we were here, and this is what it sounded like to be alive. Long after humanity itself may be gone, Voyager 1 may still exist, drifting silently through interstellar space, carrying our voices without any living person left to speak them. It won't be remembered as a machine anymore. It will simply be proof that once, for a brief and remarkable moment in the history of the universe, a civilization looked up at the stars, built something with its own hands, and sent a message outward, not knowing who, if anyone, would ever hear it. Somewhere out there right now, growing fainter each year, that message is still traveling. And whether or not we ever learn who receives it, Voyager 1 will keep going, carrying the story of everything we ever were, long after the last signal fades into silence.